Hi guys, thanks for tuning into my channel. I'm putting together my my roof plate, as you can see, and my daughter Logan is actually helping me tour the roof. So she's taking me for a tour around the roof just to give you a bit of an idea. Thanks, Logan. All the way around, just to show our viewers, and all the way through there, sweetie. All the way, just slowly back through there and all the way through there and then back around. And now I just want to show what we've actually got. So I've got my hip rafters here. I'll just take this hip rafter off for the moment, and I just want to show you our gauge. So using our template, which I showed you on the other video that I use as a guide, and I've got this gauge that I place on the top here, and that's plumb all the way through. That's my plumb line all the way through, and I'll use that to help me determine our rafter length in terms of getting our guides along there and getting our guides along there. And this tool is actually going to be used on every single rafter. Okay, it's a standard 22.5 degree pitch, and I want to also show you, just as an example, this is our rafter, or let's say this is our crown end rafter, just as an example. I just want to show you how simple this is. Once I've placed the gauge along there and the gauge along there, using our gauge here, I then actually use a 25mm thick piece of timber, and I place it along there. I place it on there, and there's my seat cut. And if I come around this way, there is my heel cut through there. Okay, that's my heel cut through there. It's a simple device to use, very easy to use, guys. And it's made up, as I say, it's made up of a seat cut, and it's made up of a heel cut, and it's no more than 25. This is 25mm thick. So as a guide, when you're looking at your building codes, you'll find the building codes will actually say that the bird's mouth is not to be cut any more than a third of the depth of the timber. This is 90mm wide, so we do not want to cut any more than 1/3 of the depth of the timber, simply because it takes away the integrity of the strength of the timber. And because the bird's mouth is designed for having the load of the roof be supported via, be transferred through the load-bearing walls, through the top plates, and down through the walls and down into the foundations. That's the idea of it. Now, with that in mind, what we need to work out is we need to work out this height through here. We need to work out a height through there, because having that height through there will actually help us determine this rafter length through here. What we do know, for example, we do know that this distance is 420mm wide, 2mm across there. I've got my little triangle here, and what I've done is I've made this 420mm. Our angle is 22.5 degrees, and we're working out our height. So we want to find our height from this point. Just come around here, Logan. From this point through there, and I'll just mark that just to show you that line through there. Okay, guys. So I place that along there, and what I want us to find this height here, and that height, which when we use tan 22.5 is equal to the height over 0.42, we get a height of 174 millimeters. 174 millimeters. That height is really important, because we can use Pythagoras' theorem. In this instance here, we use Pythagoras' theorem to calculate this rafter length here, because we do know that there is a known distance here. This rafter length distance there is this part here, which is 0.174 times 0.174 plus 0.42 times 0.42, which is equal to the rafter length as well. So we're using basically the Pythagoras' theorem. So this rafter length is equal to the square root of the base squared plus the height squared, which is there. And that actually gives us a total of 455 millimeters. That's this rafter length through there. Now, all I want to say now is, because we're starting from this side here, we don't know how far forward this is going to move. So what we do know is that because we know that our height is 174 millimeters on this rafter here, for example, we know that the angle is 22.5 degrees. Because we've got an angle and because we've got an opposite, in this instance here, we can also use, sorry, not this one, we can use sine theta is equal to, sine of 22.5 is equal to 0.174 divided by our rafter length, which is that. So when we transpose our rafter length is equal to 0.174 divided by the sine of 22.5, which is actually equal to 0.455 meters or 455 millimeters. So what that means, guys, is that when we've got our calculation of 0.455, I can place any timber, I can use any timber, I can place my gauge there, and I can put a line, say that line through there. And that means from this distance here, we would come down 455 millimeters. Let's say it comes to there, for example, and we would place our gauge through there. So that becomes our rafter length through there. And then what this actually means is once we've done that, we can then use our 25 mil and place that like so. And that's our seat cut I've marked for you there. Okay guys, that's our seat cut. Our seat cut through there, and that's our heel cut through there. Just by basically doing that, because that's 90 degrees to our guide. And then that's what we've actually got here, guys. So that's basically how we start to set up the roof for getting students to become familiar with using the gauges and a little bit of mathematics, very basic mathematics, but having these templates on board will make the journey just that little bit more easier because visualizing it. I hope that helps, guys, and I hope that makes it a little bit clearer. I'm going to put a couple of roof tiles on the top once I've completed it, and then I'm going to give you a bit more of the picture. So I just want to say thanks for subscribing, and please, subscriptions coming through, and great with your views, and please by all means make some comments as you see fit. So thanks guys, see you on the next one. Bye.